Hi. This is an aircraft carrier problem. It's kind of an interesting problem. The angles in it are the challenge, really. Um, let's take a look at it. A plane takes off from an aircraft carrier and travels a course of 240 degrees. So think about that. That's north would be 0, east is 90, south is 180, west is 240. So not quite west, but in that direction, towards the left, at 800 miles per hour for 30 minutes. Now, 800 miles per hour for 30 minutes means it travels how far? Of course, 400 miles. Then the plane takes a banking turn, consider that a vertex, and proceeds on a new course of 110. So that's not quite east, but a little bit south of east for 15 minutes at the same speed. So 15 minutes at 800 miles per hour would be 200 miles. It's now time to head back to the aircraft carrier, which hasn't moved. How far is it and at what bearing? It's really important that the pilot gets the bearing correct because an aircraft carrier, as big as it is really hard to find out in the middle of the ocean from an airplane. Lots of bright sun, hard to see, and it just doesn't stick out that much if you don't get it right. So let's take a look at how to do this problem. First, we're going to diagram it out. That'll be a really important step. Diagramming it out is critical. And show you how to do this with the north-south lines that are very important to figuring out your diagram and figuring out that bearing, and then the length of it. So first we're going to make a diagram. So here's the aircraft carrier, and 240 degrees it's headed. So here's your north-south line, just to throw it in there. And this is 180, this is 270, so 240 goes something like this. And this is 400 miles, because we said 800 miles per hour for 30 minutes. And then we draw another north-south line. And now we're going to head 110, so 90 degrees, a little bit more than that, something like this, for 200 miles, which is about half this length, so maybe a little bit longer, something like that. It's 200. And then we're going to try to head back. So we want to know the length of this line and its bearing. Its bearing is going to be off of north-south. So we're actually looking for this angle here. All right, so that's what we're looking for. Now, what do we know in this scenario? We know that, as example, this angle here is 60 degrees, or this angle here is 120 degrees. I'm going to mark this one as 60 degrees. Well, no, let's mark this one 120. So if this is 120, that means that this is 120, or this is 60, right? Alternate interior angles. These north-south lines are parallel transversals. So parallel transversals you studied in geometry, super important in this scenario. These are parallel. This is 120 are 120 and 120 are alternate interior angles. 60 and 60 are alternate interior angles. That helps us figure out what this angle is, right? Because if this is 60 and we knew that this whole thing was 110, then this must be 50 degrees. That's the angle between the two sides of our triangle. That's 50 degrees. There's other ways to get there. You could say that this whole thing was 120 and subtract this whole thing was 120, and then that means that this is 60. We had 110. There's lots of different ways to get there, but that angle is 50 degrees. So then we can figure out what the distance is coming back using law of sine. So that's not going to be too bad. The distance squared is going to be equal to 400 squared plus 200 squared minus 2 times 200 times 400 times cosine. This is law of cosines. Cosine of 50 degrees. And D works out to be 311 miles, 0.695. 311 11.695 miles. Okay, so now we have that distance. All right, but we don't know what the heading needs to be yet. So we need to figure that out. Now, thinking about this, you could use law of sines if you wanted to, because you have a side and an angle, and you have another side, and you have the angle you want. Now remember, in figuring out the angle of this triangle, that's not actually the heading that we want, but it gives us the area of the triangle. So we could try to figure out this, but in law of sines, you got to consider the ambiguous case. So the ambiguous case, law of sines always gives us acute angles. This very well could be an obtuse angle. It looks like an obtuse angle. It could be an acute angle though, because we don't really know how accurate the diagram is. You're better off using law of cosines when you're not sure if this is a obtuse or acute angle. And sometimes it's going to be really, really difficult to know. So law of cosines, how's that going to work? We have a side, and a side. So we can figure out an included angle if we consider this blue angle to be C and consider 400 to be C squared. So the length C. So let's see. We're going to do something like 400 squared is going to equal, we got to do these two sides. These are the two sides that are including our angle. That's unknown. I'm going to call this angle C. I know you like to use C for that. 200 squared plus 311.695 squared minus 2 times 200 times, going to just continue this down here, 311.695 times cosine of C. We're going to calculate for C. So you got to square this, subtract this, divide by the negative version of this, and then do cosine inverse. And doing all that, you should get that C equals 100.56 degrees. So C is equal to 100.56 degrees. Now, that doesn't give us our heading yet. We still need to figure out what direction this is in, which goes back to this green angle. Now, what do we know here? If this is 60 degrees and this is 50 degrees, we know that this together is 110. That means that this is 110 because those two angles are alternate interior angles again. Here's your parallels. This is your transversal. These are alternate interior angles, and they're congruent. So that's 110. So if that's 110, then this part, let's use this color, then this part is going to be 70 degrees. And that means the green part is going to be 100 minus 70 degrees. So that's going to be 30.56. And since that is a measurement from north, that is our bearing, 30.56 degrees. So the answers to our question are we're going to travel at a bearing of 30.56 degrees for 311 miles, and we're going to ride back to the aircraft carrier.